Good morning, students. This is Anjali, Assistant Professor, Department of CSE, AIML, IARE, Hyderabad. Today's our topic is box plot. In previous class, we have seen data visualization using the scatter plot. Why we have used the scatter plot? The scatter plot is picturized format data. That means what we are doing, whatever you have collected the raw data, you will show that data in the form of the graph. And you know that the graph have so many types, like you can show scatter plot, box plot, then line chart, bubble chart, fever chart, pie chart. So many charts are there, and every chart has its own specifications. So in last session, we have seen the scatter plots, where if you have to draw the scatter plot, so definitely you will need the two axes, like one is x-axis and another one is y-axis, and on that basis, you will find out the sum of the values, and on that basis again we have seen that some types of the scatter plot, like strong correlation scatter plot, moderate correlation scatter plot, and no correlation scatter plot. In strong correlation means if you have two axis, x-axis and y-axis, and now you are drawing this plot like this, and from this you can plot the line, you can draw the line. That means it is showing the relationships of the values, relationships of two values, and these values are very close to each other. But this is your strong correlation. In moderate correlation, what will happen? Sometimes these variables also are close to each other, but not so close to each other. We can't draw the straight line from this. It's possible in the strong correlation. So this is your moderate correlation. And no correlation means your points are like scattered in the plot. So here you cannot show any relationship, no relationship between the variables, or you can see between the values. So this is your showing no correlationship. So this is all about the scatter plot. Now our main topic is box plot. We will start the box plot. These are the contents. Box plot. Parts or components of the box plot. Box plot distribution. Uses of box plot, and how to compare the box plot. We will cover one by one. First, a box plot. What is meant by box plot? When we display the data with distribution in a standardized way using 5 summaries like minimum, Q1 that means first quartile, median, Q3 that means third quartile, and maximum, it is called the box plot. It is termed as box and whisker plot. The method to summarize a set of data that is measured using an interval scale is called box and whisker plot. That means box plot containing 5 portions, with that 5 portions of minimum, first quartile, median, third quartile, and the maximum. Every quartile has its own specification. So we will see one by one. There are maximum use. These are maximum used for the data analysis. And we use these types of graph or graphical representation to know the distribution shape, central value of it, and the variability of it. Actually, box plot is chart that shows the data from 5 number summaries, including one of the measures of the central tendency. It does not show the distribution in particular as much as the stream and leaf plot or histogram does. But it is primarily used to indicate a distribution is skewed or not, and if there are potential unusual observation, also called outlier, present in the data set. Generally, box plots are very beneficial when large numbers of data sets are involved or compared. In simple words, we can define the box plot in terms of descriptive statistics related concepts. That means box or whiskers plot is method used for depicting groups of numerical data through their quartiles graphically. These may also have some lines extending from the boxes or whiskers which indicates the variability outside the lower and upper quartile. Hence the term box and whisker plot and box and whisker diagram. Outlier can be indicated as individual points. It helps to find out how much the data values vary or spread out with the help of the graph. As we need more information than just knowing the measures of the central tendency, this is where the box plot helps. This also takes less space. It is also type of pictorial representation of the data. Since the center, spread and overall range are immediately apparent using these box plots, the distribution can be compared easily. Now there are different parts of the box plot. First one, minimum. The minimum value in the given data set. Whatever you have a data set, there will be one of the minimum value. Then first quartile, that means we can show as a Q1. The first quartile is the median of the lower half of the data set. Whatever you have a lower half data set, so that portion, for that portion we will get the one of the median value. Then what is meant by median? The median is the middle value of the data set which divides the given data set into two equal parts, and the median is considered as the second quartile. Third quartile is the median of the upper half of the data. The maximum value in the given data set. Apart from these 5 terms, the other terms used in the box plot are interquartile range and the outlier. Interquartile range means difference between the third quartile and the first quartile, which is known as the interquartile range. So we can show IQR is equal to Q3 minus Q1. Then outlier, the data that falls on the far left or right side of the ordered data is tested to be the outlier. Generally, the outliers fall more than the specified distance from the first and the third quartile. Here you can see that this is your median. Our values, our range are 4 to 12. 12 is the largest sample value and 4 is the smallest sample value. So this 4 is your minimum value and this 12 is your maximum value of the range. Then first we need to find out the median. So this is your median. This value is 8 is your median. 8 is your median. So this is your median value. Now we have to check lower quartile and upper quartile. What is meant by lower quartile, upper quartile? So this is the middle half of the sample. And after that, if you are going to left side, that means 1/4 of the sample, and if you are going to right side, 1/4 of the sample. That means these are every type, there are different quarters from the both sides. Then this is your lower quartile and this is your upper quartile. And median, you got the median values. So there are, when if you got the median value, so at that time you will get the two half portions. First one is 1/2 of the sample and another one is the another half portion of the sample. And again, this is your box plot. Here we got the box plot, and the box, this is showing the interquartile range. That means quartile 3 minus quartile 1 value. Every box plot has two parts. One is a box and another one is a whiskers. As you have seen already in the figure. That's why it is called sometimes box and a whisker plot. The start of the box is called lower quartile, that is represent the 25% of our data set. By looking at the diagram, we can instantly conclude that 25% of our data has a value less than 6.2. You can see here. Similarly, the end of the box, that is the upper quartile, represents 75% of our data. So again, from the diagram, we can conclude that 75% of our data is less than 8.8. The bold black line in the box represents the median value of our data. In our example, median lies at about the 7.8. Right? Median lies as a point of 7.8. So in our example, difference between lower quartile and the upper quartile, it is called the interquartile range. And so basically entire red box represents the interquartile range of your data set. Now the following diagram will explain the quartile in further. So here the range is from 200 to more than 325. We can consider 375. So here, this is your box plot. In box plot, this is your upper whisker and this is your lower whisker. And this line, this point is showing your upper quartile and this point is showing your lower quartile. This line, this point is showing your middle quartile. That means we can say it is the median. So in this quartile 1, this 25% is showing that the quartile 1 group 1. This 25% is showing the quartile group 2. This 25% is showing that quartile 3. And the remaining 25% is showing as the quartile group 4. Now for outliers. Now let's talk about the whiskers of box plot and how do we visualize the outliers in the box plot. In the box plot, whiskers are generally defined as 1.5 times the interquartile range. That means, box plot, the whiskers are generally defined, it is 1.5 times the interquartile range, and anything this outside, the whisker is considered as the outlier. So here, this is again your box plot. Box plot is showing for energy and machine. So, lower quartile, upper quartile, everywhere you will get the lower quartile, upper quartile, and everywhere, in every plot, you will get the 5 portion, lower quartile, upper quartile, then median, outlier, everything will be available, maximum, minimum, everything, every value will available in your box plot. So, how we have to identify the skewness? We can also identify the skewness of our data by observing the shape of the box plot. If the box plot is symmetric, it means that our data follows a normal distribution. If our box plot is not symmetric, it shows that our data is skewed. And if you can get the better understanding by looking the diagrams, so this is your normal distribution. Quartile 3 minus quartile 2 is equal to quartile 2 minus quartile 1. Quartile 1. So this is your, that means you can see here both portions are the same. So this is your normal distribution. Positive skew means this portion is small one and another one, this is large one. So this is your positive skew. That means quartile 3 minus quartile 2 is greater than quartile 2 minus quartile 1. That's why this is your positive skew. And then negative skew, that means quartile 3 minus quartile 2, it's less than quartile 2 minus quartile 1. So it is a negative skew. So here is a box plot with respect to the distribution curve. This is distribution curve and this curve is shown in the bell shape. This is your box plot. Quartile 1, quartile 2, quartile 3 and this is your quartile 2. Now let's see 5 values required for creating the box plot. So this is your range. In this range, we have lower extreme value and the upper extreme value. 12 is your lower extreme value, 86 is your upper extreme value. So after that, we have to find out the median value. Which is the median value? So here 58 is your median value. So now we will draw the box plot and the whisker. On this basis, on the basis of this value, we will plot our box plot. So box plot, lower value is 12, upper value is 86. After that, we have to find out the median. We got the median as a 58. So this is your median value. Now you have to find out 25 is lower quartile and here 72 is lower quartile. That means on this, here this is your median, this is your median. So both of these parts, we have again got the two medians, 25 and 72. 25 will come in the lower quartile and 72 will come in the upper quartile. So this is your box plot on these values. That means every time you have to find out the median value and on that basis you have to draw your box plot. Now box plot distribution. The box plot distribution will explain how tightly the data is grouped, how the data is skewed and also about the symmetry of the data. So there here quartile 1 minus 1.5 into interquartile range. That means these are your outliers. So this is your Q1, Q2 and this is IQR. And again there are two outliers. So here probability box plot of normal distribution. You can see this is the normal distribution table, probability density and these are the value and this diagram is showing the bell-shaped value, bell-shaped diagram. So here you can show all this data and this is the box plot distribution diagram. There are three types: positively skewed, negatively skewed and a symmetric. Positively skewed, if the distance from median to the maximum is greater than the distance of the median to minimum, then the box plot is positively skewed. If distance from median to minimum, in positively, median to maximum, if distance from the median to minimum is greater than distance from median to maximum, then the box plot is negatively skewed. And the symmetric, the box plot is said to be symmetric if the median is equidistant from maximum and minimum values. So at that time, it is the symmetric. Now how we have to create the box plot? Let's take sample data to understand how to create the box plot. Here are some runs scored by cricket team in a league of 12 matches. And these are the range, these are the values. To draw the box plot for the given data, first we need to arrange the data in ascending order. Then we will find out the minimum value, then first quartile, median, third quartile and the maximum value. So here, first we will arrange our data in the ascending order. And we have arranged all the data in the ascending order. Now first we will find out the minimum value. Here this is your minimum value. 220 is your maximum value. And now we have to find out the median. So what is your median? Between these values means it is median, that means 125. Since there were even values, that's why we have got this median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this portion will contain 6 values, this portion will contain 6 values. So there is no, we can't find out directly median value. So what we will do, we will add this 120 plus 130 and divide by 2. So we will get the median value. 125 is our median value. After that, now again we have to find out first quartile value and second quartile value. Again here also we can't find out directly first quartile value. So what we will do, again we will add this value and we will divide this value. So we will get the first quartile value is 110. Then we have to find out third quartile value. Again here also we have to add this value and we will get the third quartile value. Now if the total of the values is odd, then we exclude the median value, calculating quartile 1 and quartile 3. Here, since there were two central values, we included them. Now we need to calculate the interquartile range. Now how we will calculate the interquartile range? Your interquartile range is equal to quartile 3 minus quartile 1. Your quartile 3 value is 145 and quartile 1 value is 110. So now you will get the 35. Now we can calculate the upper and lower limits to find the maximum values and also the outliers if any. Now we have to find out the lower limit. Lower limit, how we will find out? Quartile 1 minus 5 into interquartile range. And this is, now you will get the 57, we got the 57.5 is our lower limit. Upper limit, we have to find out again quartile 3 plus 1.5 into interquartile range. Now we got the upper limit 197.5. So the minimum and maximum between the range 57.5, 197.5 for our given data are. That means minimum is 100, maximum is 170. That means the outliers which are outside the range are 220. Now we have all information, so we can draw our box plot. Quartile 1 110, quartile 2 145, minimum is 100 and maximum is 170. And quartile 2, that means it is our median is 125 and 220 is our outlier. We can see from the diagram the median is not exactly at the center of the box and one whisker is longer than the other. We also have one outlier. So now we will see the uses of the box plot. The box plots provide the visual summary of data with which we can quickly identify the average value of the data. How dispersed the data is, whether the data is skewed or not. The median gives you average value of the data and the box plot shows skewness of the data. If the median is the center of the box and the whiskers are almost the same on both the ends, then the data is normally distributed. If the median lies closer to the first quartile and if the whisker at the lower end is shorter, as in the above example, then it has a positive skew. That means we can say it is a right skew. If the median lies closer to the third quartile and if the whisker at the upper end is shorter, then it has a negative skew. That is your left skew. This is your normal distribution. See, both whiskers are the same. Positive skew. This whisker is less than this one. Negative skew. This whisker is greater than this. So this is your negative skew. Now the dispersion or spread of data can be visualized by the minimum and maximum values which are found at the end of the whisker. The box plot gives us idea about the outlier, which are the points which are numerically distant from the rest of the data. Now, how to compare the box plot? As we discussed at the beginning of the article, that box plot makes comparing characteristics of the data between the categories very easily. Let's have a look. We can compare with different box plots and derive the statistical conclusion from them. Let us take below two plots as an example. This is your plot A, this is your plot B. So we have taken as an example. Let's compare the median. First, compare the median. This is the median of the plot A and this is the median of the plot B. Now, if the median line of the box plot lies outside the box of the other box plot with which it is being compared, then we can say that there is likely to be a difference between the two groups. And here the median line of the plot B lies outside the box plot A. Now compare the dispersion or the spread of the data. The interquartile range, that means the length of the box, gives us idea about how dispersed the data is. Here plot A has a longer length than the plot B, which means that the dispersion of data is more in plot A as compared to plot B. The length of the whisker also gives an idea of the overall spread of the data. And the extreme values, that means minimum and maximum, gives the range of the distribution. And the larger range, more scattered the data. Here plot A has larger range than the plot B. Now comparing the outliers. The outliers gives the idea of unusual data values which are distant from the rest of the data. More number of outlier means the prediction will be more uncertain and we can be more confident while predicting the values for a plot which has less or no outliers. Then next one is compare the skewness. Skewness gives us the direction and the magnitude of the lack of symmetry. And we have discussed that how to identify the skewness. Here plot A is a positive or right skewed and the plot B is negative or left skewed. These are all about the box plot. In box plot we have seen how different components of the box plot, that means the minimum, first quartile, median, third quartile and maximum. Then we have seen some portion, one of the example. After that how to identify the skewness. In skewness there are again three types, that means normal distribution, positive skewness and a negative skewness. Then how box plot distribution. After that again we have seen one of the example how to create the box plot. So this is all about the box plot and where we can use the box plot and how to compare the box plot. In box plot we can compare the medians, we can compare the dispersion of the spread of the data, then we can compare the outliers and we can compare the skewness of the data. This is all about the box plot. These are the references, so you can go through these references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.